So, hello, thank you for watching this video. So in this video, I'll be doing question 4 of November 2020 question paper, Mathematics paper 1. So question 4.1 reads as follows. So, write down the equations of the asymptotes of h. So they want us to write down the equations of the asymptote of this function, which is h of x. So, this function here is a hyperbola. So a hyperbola have two asymptotes, a vertical asymptote and a horizontal asymptote. So a horizontal asymptote, you write it which is horizontal, so which means it's cutting through the y-axis, so it will be in the form y is equal to. A vertical asymptote, which is vertical, it cuts the x-axis, so it's going to be x is equal to. So we are going to find those two asymptotes. So 4.1.1. So that's saying the equation of the asymptote. I'm saying we have two asymptotes, a vertical asymptote and a horizontal asymptote. A horizontal asymptote is moving this way. It is in this orientation, which means it's horizontal. It's cutting through the y-axis of the Cartesian plane. So it's going to be expressed as y is equal to a vertical asymptote, which means it cuts through the x-axis. X-axis are horizontal, so it cuts through the x-axis, so it's going to be x is equal to. So let's go there. So the vertical asymptote, so the vertical asymptote is going to be in the form x is equal to. So read it from here. So x is equal to 1. So we will have the asymptote that x is equal to 1. So why is this? Because I transpose the negative one to the other side. Why is the asymptotes there? The reason is this because this function, this hyperbola of ours, will not be defined at h is equal to 1. So if I say h at 1, I'm going to have negative 3 over 1 minus 1 plus 2, which is equal to negative 3 over 0 plus 2. You know this cannot happen. You can't divide by 0. So that's why we have our asymptote there. So throughout this function of ours, this graph, this function will not be defined at x is equal to 1. So if you are defining a domain of this function where it will be defined, it will be defined everywhere except that point x is equal to 1. That's your vertical asymptote. Then let's go to the horizontal asymptote. Horizontal asymptote. So, your horizontal asymptote is horizontal, as it says. So it cuts through the y-axis, because the y-axis vertical is a vertical, whatever. So it will be in the form y is equal to. So y is equal to what? We have used this part and obtained this vertical asymptote. So the remaining part is that one. So your y is equal to 2. So your horizontal asymptote is at y is equal to 2. This is your horizontal asymptote. This is how you answer this question. So just x is equal to 1 and y is equal to 2. So these are your asymptotes. So yes. So how do you, okay, let's leave it here. So let's go to the next question, 4.1.2. Read as follows. Determine the equation of the axis of symmetry of h that has a negative gradient. So a hyperbola have the axis of symmetry. What is the axis of symmetry? So it is an axis of symmetry. It is a symmetrical line. It is a line. It is a line that cuts your graph into two identical parts. That's what an axis of symmetry is, which means symmetry, which means symmetrical. So if you're saying this is something is a line of symmetry, it means that on either side of that line of symmetry of yours that you have, you will see two identical features. You will see identical features. That's what it means. So, hyperbola does have the axis of symmetry. So, it is defined by these two lines. By the line y is equal to minus x plus c, or y is equal to x plus c. So, this one have a negative gradient, and this one have a positive gradient. So how do you know which one to use? Here in this case, you are told which one to use. They are saying use the one with the negative gradient, which is this one. So on another day, you might be asked, without being told which one to use, how do you determine which one to use? So what gives you a hint of which one you should be using is your nature of your graph, which is the sign of your graph. This function here is negative. This is where you read the sign of your graph. Provided that the entire structure is in this form, which is you have x minus something, or x plus something, plus whatever. So this is where you read your sign. But if you have something like 1 minus x, then you must rearrange that in such a way that it fits this format. X minus something, x plus something. So if everything else stays similar to this, we say you have x minus p plus q, then this is where you read the sign of your graph. Because now, the reason I'm saying this, if this x here was negative, it was negative x minus 1, then this would be a different story. The sign of this graph would be different, the sign of this function. So this is where you read the sign of a function. So if this graph is negative, if your function is negative, then what that means is your graph will be negative. That means you must use the line that have a negative gradient. And that line, it does cast your function. But what you also need to know is that it passes through the point, the point where your asymptotes meet. Because you have a vertical asymptote, we have a horizontal asymptote. So this line of symmetry, which is this line, because in this case the graph is negative, which means we are going to calculate the line of symmetry using this equation here. Using this equation here. So what it means is this line of symmetry passes to the point where your asymptotes meet. So your asymptote, you said the other was x is equal to 1 and the other was y is equal to 2. So this graph passes at 1 and 2, this line of symmetry. So what you have to do now is to find this equation. How do you do this? Easy. We have x, we have y. So y substitute 2 minus x, which is 1, plus c. So your c is equal to 2 plus 1, because you transpose this to this side. So your c is equal to 3. Your line of symmetry is equal to y is equal to negative x plus 3. So if you plot the function that you're given h there and plot this line, you'll see that this line will split your graph into two identical parts. This is your line of symmetry. But if your h was positive, you're going to use that graph with a positive gradient. So let's go to the next question. Okay, so we proceed to the next question. Question 4.1.3 reads as follows. Sketch the graph of h showing the asymptotes and the intercepts with the axis. So they want us to plot the graph of h to show the asymptotes and what? And the intercepts with the axis. So let's start with our function. So we're going to do question 4.1.7. What is it that we know? So let's suppose that we are drawing this function now. So this is our Cartesian plane. Have it here. This is y axis. some people call it x is equal to 0. Because I said, if you're saying x is equal to, which means that line of yours is vertical, it's a vertical line. So x is equal to 0, which means along this line, x is equal to 0 along this line. Along this line, if you say somewhere here, x is greater than 0 here, somewhere here, x is less than 0. So this is the y-axis, also known as line x is equal to 0. So here we have the x-axis, which is also known as y is equal to 0, because along this line, y is 0. Above this line, y is greater than 0, which is positive. Below this line, y is less than 0, which is negative. So this is very important. You must know this, because we are going to need it. So above here, if you have a line that crosses here, it is called, and it's horizontal. It's going to be y is equal to something, whatever constant that is this line is passing through along the y-axis. And below here is y is equal to whatever that is negative below the origin. Similar with x, some vertical line crossing here is x is equal to something positive. Along this line is 0, this side is negative. Important. Then, what do we know? We know the asymptotes that we did on the first question. We said x is equal to 1 and y is equal to 2. So the first thing that we do is to plot these asymptotes. So y is equal to 2, which is going to be a horizontal line, similar to this one here. So these two lines are parallel. So y is equal to 0 is this line here, and x equal to 0 is this line here, which means the distance between these lines is always the same, and it's always equal to 2. So say we have 2 here. So here is our asymptote. So we did do it as a dotted line so that we don't get confused. So it can be easier to spot. A vertical asymptote is x is equal to 2, x is equal to 1, it's vertical here, and it's parallel to x is equal to 0. So let's say 1 is somewhere here. Its asymptote is here. Other is the continuation, the same asymptote. So this line here is x is equal to 1, and this is y is equal to 2. And then what else do we have? We have the line of symmetry. We said the line of symmetry passes through this point here. And it's negative. It's a line. It's a line of symmetry. So this line goes up, continues in that direction. So this is the line y is equal to negative x plus 3, which means it's cutting the 3 here. Because we said it passes through the point where your vertical asymptote and your horizontal asymptote intersect. So they meet there, they intersect there. So now the only thing that is missing is the function. So, but in order for us to draw this function, we need to plot, we need to know the asymptote, the intercepts. Because we know the asymptotes, we know the line of symmetry. But we didn't need to show the line of symmetry because they didn't ask for it. But I just plotted it out because I wanted to show you, because I wanted to explain further what I was talking about. Because I don't think they did ask for it here. Let me check it. No, they didn't ask for axis of symmetry. I plotted the axis of symmetry because I wanted to show you that, so that you can see it's a straight line that passes through that point, and it has a negative gradient, hence it's moving that direction. Then, the only thing that is missing are the intercepts. So let's go find the x-intercept and the y-intercept. What is the x-intercept? What is the y-intercept? So, when you're talking about the x-intercept, which means your graph is intercepting when you're talking about the x-intercept, which means that your graph is intersecting the x-axis, which means it passes through the x-axis. So these are your x-axis, which means your graph is passing somewhere along this line. When you talk about the x-intercept, which means your function is passing through the x-axis. So that's what you are talking about. When you're talking about the y-axis, which means your graph passes along. When you talk about the y-intercept, which means your graph is passing along this line here. That's what you mean. X-intercept passing through the x-axis. Y-intercept is passing somewhere, anywhere somewhere around here on the y-axis. That's what you mean. And then, now, let's go and find that. But as I said, if something is passing on this line, we already know its x value. That along this line, x is equal to 0. Along this line, y is equal to 0. If I'm talking about the x-intercept, which means our graph is passing somewhere along this line, and we know our y value there. If we're talking about the y-axis, which is a y-intercept, which is our graph, our function is passing along this line, and we know our x value is equal to 0. So you should always know that. So let's go and find these intercepts. So, said h of x is equal to minus 3 over x minus 1 plus 2. So, let's start with the x-intercept. So, start with the x-intercept. So, if you're talking about the x-intercept, which means this graph is passing on the x-axis, which means it's passing here. I'll go back to this line because this is important. So, it's passing on this line here, on the x-axis. So, it's passing along this line, So your graph will cut somewhere there. See, this one is intersecting there. So this is your x-intercept for this function here. So, as I say, it's passing along this line, and you know your y is 0 there. So, before you even continue, you say, okay, I want to know why is it cutting on the x-axis. As it is cutting there, I know for sure y is 0 there. So, you say, okay, we here. So you say, okay, x-intercept, you know y is equal to 0 then. Which means your y is 0, which means this part is 0, because this is your y part. This is your function is depending on x, which means this is your y. So you know that this part is 0 there. So the only thing that you do, say, okay, instead of in the place of y, which is this, I place 0 is equal to negative 3 over x minus 1 plus 2. Then you take this to this side. It was negative, it will be positive when it gets here. 3 over x minus 1 is equal to 2. And then you cross multiply. 1 times 3 is 3 is equal to 2x minus 1 times 2, which is x times this. It's going to be 2 times that. Then you simplify this. This 3 is equal to 2x minus 2. Transpose this to this side. So you have 3 plus 3 plus 2 is equal to 2x. Then you remove this 2 here by dividing by 2, divide by 2. So your x is equal to 5 over 2. So you found your x value, 2 will be 5 over 2. What that means is you have the coordinates for your x-intercept. So because you found your x to be 0, you knew you found your x to be 5 over 2, you knew your y was 0 there. Because along that line, this line y is equal to 0. That is the x-axis. Go do the similar thing for the y-intercept. So the coordinates of the x-intercept, what are they? what is it? Okay, I'll write them on the other page. So the coordinates of the x-intercept are 5/2 and 0. So you go to the y-intercept. For the y-intercept, so y-intercept, I said that, which means now it's cutting along that vertical line there. Somewhere along that vertical line on the Cartesian plane. I said y-axis are also known as line x is equal to 0, which means now you know your value of x. The only missing thing is your value of y. Then what is it? So how do we find it? We say, okay, h of x is equal to minus 3 over x minus 1 plus 2. And then, okay, I'm sorry that it appears like this, but I did the entire question, but my camera stopped the recording. So it cuts off after 12 minutes all the time, so I should have placed a timer. So what I did from this step here, you say you know your x is equal to 0, then you substitute your x is equal to 0 on your function, so which is here, that's how you get your y, because this is your y value at that point. Then you substitute your 0, which is that, then you punch this on your calculator, or simplify it, it will become 5. So once you know your 5, this is your y value, you know your x value because it's along the y-axis. And along the y-axis, you know x is equal to 0. So this one is it's very straightforward. Take that 0 that you know and substitute it here on your equation to find the corresponding y value. So you found that the corresponding y value is 5. So you know the x value is 0, which is the coordinate is 0 and 5. So you take this point, this y-intercept and this x-intercept and go plot them on your function. So in this case, I already did because, as I said, my camera stopped working and I thought it was still recording. So this is how it looks like. Okay, so this is your 0 and 5, your x is 0 there, your y is 5. This is your shape of your parabola, which you know, and it's negative, that's why it's on these sides of the asymptotes. And that is your x-intercept, which is 2 and 0, that is that one there. This is how your function looks like. So, because the only thing you do is just to plot those 2 points, which is 0 and 5, and 2,5 and 0, which is 5/2. So this is that, and this is that. Then you just plot the shapes. Because when you're plotting the function, any function, depending on the nature of the function, the most important things are the intercepts, if it does have, the asymptotes, if it does have, and the turning points, if it does. So those things must be clear, and the shape of the function must also be clear. So it's the asymptotes if you have them, the intercepts if you have them, it's your turning points if you have them, and the shape of the function. So, and provided that everything is clearly labeled. X-axis is line x is equal to 0. Once you have this in mind, you know that if something is passing through the x-axis or the y-axis, you know your x is equal to 0. If passing along the x-axis, you know if something passing along the x-axis, you know y is equal to 0. Passing on the y-axis, x is equal to 0. So this makes it easy for you, because you should know that if you talk about the x-axis, it's the same as line y, x is equal to 0. Because this vertical line here, which is here, is the same as that. So I'm done with this question, this section of this question. Let's go to 4.2. Okay, so now let's do question 4.2. The graphs of f and g are sketched below. So here the function f is given by this equation. Here is the sketch of f. Here is g of x, the graph g. Here is it here. It's this straight line. So f is the parabola and g is a straight line. So let's read the question. The graph of F and G are sketched below. A is the turning point of F. A is the turning point of this function here. So A is the turning point of this graph. The axis of symmetry of F intersects the axis at E and the line G at D. So we spoke about the axis of symmetry. I said the axis of symmetry on the first question of the parabola, of the hyperbola. I said the axis of symmetry, it is a line that splits your graph into two symmetrical parts or two identical parts. This one is handwritten. So if it was drawn by a machine or some software, it would be more clear than this. You see, okay, so what they're saying is that the axis of symmetry of F intersects the x-axis. So the axis of symmetry of this function here is this line here. So, which means if you were to plot this function nicely and plot this axis of symmetry, you see that it's symmetrical about this line. It looks exactly identical around this line. So whatever point that you can find there, you can find a similar point, similar shaped point in this case. So now they are saying that the axis of symmetry intersects G at the turning point, intersects the x-axis, and also intersects this function. The line of symmetry or the axis of symmetry of G of F, because the axis of symmetry it belongs to this function F. It intersects the G, it intersects the x-axis, and it intersects the turning point. So that's what they are saying. The axis of symmetry of F intersects the x-axis at E, which is intersects the x-axis at E, and the line G, and the line G at D, so which means it also intersects this line here at D. Write down the coordinates of A. That is the first question. That is 4.2.1. Write down the coordinates of A. So, you know this function is a parabola. So, we are going to find the coordinates of A on this function here. So, since it is in this form, it's easy to find these coordinates. It's just this part and that part, like we did with the equation of the asymptotes, if it is in this form. So, which means the coordinates of A, so this is 4.2.1. X is equal to -5, and the y coordinate is equal to -8. So these are the coordinates of this turning point here, if we are given in this form. So x is equal to -5 and y is equal to -8, which means the coordinates of A is -5 and -8, which makes sense because x is negative this side of the origin, and negative below the origin. Y is negative below the origin. So these are the coordinates of that. Then we go to the next question. Write down the range of F. What is the range? That is the most important question. So I'll try to simplify it as much as I can for grade 12. So for grade 12 level, I'll define it this way. Are all values that are going to be used by this graph? So when you talk about the domain, you're referring to the x values that are going to be used by the graph. So this graph can use all the x values because there are no asymptotes or point of discontinuities on this graph. So it doesn't have asymptotes, which means this graph can use all the x-axis. So if you're writing the domain of this graph, which means this graph is defined everywhere, which means x can be any number. So x can be any number on a line, on a number line. So x is an element of real number, which means all the x values are inside the set of real numbers. That is the domain of this function. But the range, which is what we are asked about the y values that this function is going to use. Which means each x value is sent to a y value. So you want all those y values to which the x values are sent to. That's what you want by the range. They want the set of all the x values at which your graph will be sent to. For example, let's take a point here. This point here, x is 0 there, is mapped to -8. And this one is mapped here. This one is mapped here. This one is mapped here. Which means each point have a corresponding y value. So they want to find you, or they want you to find all the y values that will be corresponding to the x values. That's what they want. So what are your y values that this function will use? So the y values that this function will use are all the y values that are above this point. Because below here, which is at -9, this function does not get there. So you can't say -9, y equal to -9 is used by this graph, because this graph doesn't get below, doesn't go past -8. The function does not go past -8. So the y values that this function is going to use are all these y values, because as it continues going up, all the y values, as the x increases that direction, all the y values that are above are going to be used. Which means you're going to use all the x values from -8 going upwards. So your range should be y is greater or equal to -8. So you are starting from -8 going upwards. So to write it down, I'll say my y should be greater or equal to this one. So all the y values that are above here are going to be used on this graph, because as it becomes bigger, the y's are becoming bigger as well. So the range so 4.2.1, 4.2.2, 4.2.2. So the y values that are going to be used are going to be greater or equal to -8. That is your range. This is your range. This one here. So y should be greater or equal to -8. This is your range. Or you can say your range, your y should be inside here from -8 all the way to infinity. So I use the square bracket, which means starting from -8, and I use an open bracket because infinity is not a number, just describing that the y values will be getting bigger and bigger. So infinity, you can say to infinity, like as if infinity is a point or is a number on a number line. It's not a number on a number line, it's just a notion of showing you that this function, or the value of y, the y values are going to get bigger and bigger and bigger and bigger. So y is an element of this set. So which means y is inside this interval. So someone else can say, oh, so if you plot it, let's say now you have the y line here, so you have -8 here. So all of these y values from 8 becoming bigger. So that's how you define your range. So here's your range. So it's the set of all y values that you are going to use, that are going to be used by the function, that are available, or all of them are available, but those that are actually used by the function. So your function only uses the y values that are above -8, from 8 going upwards. So that's your range. let's go to the next question. So, the next question reads as follows. Calculate the values of m and n. Let's go to the function. They are saying calculate the values of m and n. So you know that the x value for a is -5. So if you go along this vertical line, the x value is the same. Because I said when I was doing the equation of the asymptote that a vertical line will be defined as x is equal to. A horizontal line will be defined, a vertical line will be defined as x is equal to a constant. A horizontal line will be defined by y is equal to a constant. So this line here is vertical and it is defined by a vertical line. So it is going to be x is equal to -5. So we know that along this line x is -5. So which means your m there is equal to -5 because it's your x value. Then to find the corresponding y value, you must substitute the x value that you know, which is -5, to the equation of g, so that you can find the corresponding y value of the point D, which is equal to n in this case. So you know this, so the x value is the same here, and it's the same there. So along this line, x is equal to a constant. Then you know the x value. The only thing that is missing is the y value. So let's go and find the y value. So we're going to substitute -5 into this equation and simplify it. Then we're going to get the y value. The x value, we know m is equal to -5 because they are along the same line. They are collinear. Those are collinear points, which is they are on the same line. So, say 4.2.3. We said that m is equal to -5 because it's the point E. Is it E? The point D is collinear with A and E, which means they are on the same line, which means they are on the same vertical line, which means they have the same x coordinate. So the y value, to find it, we'll say, okay, y value, which is equal to n, is equal to g of -5 is equal to 1/2 times -5, substitute on that equation of ours on the straight line, plus 9/2. Then you substitute this, you punch all this on your calculator, which means -5/2 plus 9/2. So your corresponding x value is equal to 2, which means now this is your n. So D, which is made by m and n, is equal to D, which is -5 and 2. From this question, easy. Then you go to the next question. 4.2.4. Calculate the area OCDE. So, what they're saying calculate the area of this area, OCDE. So they want you to calculate the area of this part. So the first thing that you need to do is to identify what shape is this in order to be able to find the area. Once you identify the shape, you'll be able to calculate the area. So what shape is this? Here we have two shapes. So we have this shape here, this shape here, which is a rectangle, and this shape here, which is a right angled triangle. So we have two shapes, a rectangle and a right angled triangle. So to calculate the area of this place, we must add the areas of these two things. So the area of the rectangle is length times breadth. So you know your length here, because you see from 0 to this is 5, which means the length of this place is 5 of this side. And the breadth from this to that, we said here the coordinates of D are m and n, which is -5, and 2, which is this height here is represented by y. This is 2. So you have this side to be 2. Then this side is the same as this one. It's also 5. And that is, we said that this is the intercept, right? So at the intercept, what is it? It's 9/2, which is this one here. So we have 9/2, which is 4,5. So if we have 9/2, 4,5 there, and this is 2, which means the distance that is here is 2,5. So that's what we're going to do. We're going to calculate the area of this length times breadth plus area of this, which is half base times perpendicular height. So length times breadth is going to be area of this times half base times perpendicular height, because this is a right angled triangle. So let's go and do this. So we're doing question 4.4.2. So what is it? 4.2.4. So we're going to say area of OCDE is equal to area of a triangle plus area of a rectangle. So which is equal to half base times perpendicular height plus length times breadth. So we use half base times perpendicular height because it's a right angle triangle. Or you are grade 12, you can say, okay, it's going to be AB sine theta, which is the angle between the sides, plus length times breadth. So what is your A? Which is the length of your sides of your triangle. So half AB, so half AB sine theta. So half base, what is your base? Is this side that is sitting with, the base of it, which is 5, because this, the length of this is 5, times perpendicular, which is 2,5, which is 1/2 times 5 times 2,5. That is the perpendicular height. Sine theta, which is sine theta. What is your theta? The angle between the two sides. This side and this side is 90 degrees. Sine 90 degrees plus length times breadth, which is this side times that side, which is 5 times 2. 5 times 2. Then we move. So punch this all in a calculator. Now you can simplify it, but I don't have time. 0.5, this thing might not even be recording now. 2,5 plus times sine theta plus 5 times 2. This is 65/4. Equal to 65/4. This is the area of OCDE. So you added the areas of the two shapes that you saw on this thing. So you saw that the areas of these two things are derived from two shapes, which is the triangle and the rectangle. So you do the area of this alone, length times breadth, and then add this one, half base times perpendicular height. Then you're done. Then let's go to the next question. Okay. So let's do question 4.2.5. Question 4.2.5 reads as follows. Determine the equation of the inverse of G in the form y is equal to. So they want us to calculate the inverse, to find the inverse of this function. They want us to find the inverse of this function. What is the inverse of a function? So an inverse of a function is more like you are looking for the mirror image of that function. You want the mirror image of this function. So what you do, you reflect your function about the line, about this line. About this line y is equal to x. So what you do, you reflect your function about this line y is equal to x. So this passes through the origin. So when you are finding the inverse of a function, the first thing is to reflect your function about the line y is equal to x. About that line. What does that mean? Let's go and explore that. So you reflect your function g about this line y is equal to x. So when you are reflecting your function about this line, your x and y coordinates, they become y and x. So which means your natural state of your function will have x and y coordinates swapping. So you had g of x, which is called f of x. You had your g of x, which is equal to y, to be equal to 1 over 2, negative 1 over 2, 1 over 2, x plus 9 over 2. That is your function. Your g of x is equal to 1 over 2x plus 9 over 2. So the first thing that you do, you take your x and put in the place of y, you take your y, put in the place of x. That's what that means. That's how you reflect something about the line y is equal to x. X and y coordinates swap. So now, you end up having something like x is equal to 1 over 2 y plus 9 over 2. This is what you're getting. Then now, after doing this, you solve for y, because it should be in the form y is equal to. So you want the inverse of your function. So you should solve for y when you get to this point. So you take this to the other side, you have x minus 9 over 2 is equal to 1 over 2y. And then you want to be left with y, then times 2. Times 2 this side. Then what do you have? You have something like 2x minus 9 is equal to y. So this is your inverse. This is your inverse, which is the same as saying g inverse of x. This is your inverse. So if you can plot it together with the original, you'll see that these two things are mirror images. Okay, now you will see that it's reflecting about that line. You'll see that this is a reflection. You see that this is a reflection of that, or they are reflections of each other. Not mirror images, reflections of each other. So yeah. Let's go to the next question. So, the next question reads as follows. If h of x is equal to the inverse of g plus k is a tangent of our function, determine our function f, determine the coordinates of the point of contact between h and f. Okay. So, here is what they are saying. They are telling you that we define a new function, 4.2.6. 4.2.6. We define a new function, which is what? Which is equal to h of x. Which is equal to h of x. So ignore the h of x we did on 4.1. This is another one. So they're saying we're defining another function, h of x, to be equal to the inverse of g, which is this, plus some k. So what they're saying is that this thing, you can see that this is a straight line, and that k there is a real number, it's a normal number. So k is a real number. So what they're saying is that you are having this straight line here, because this is a straight line, because if you are subtracting this 2x and put it here, it will be this k plus 9, which is also a constant. So this is also a straight line. So what they are saying is, if h of x, which is this, is a tangent to f, determine the point of intersection of f and h. So what they are saying is, your function is a tangent to this graph. Your function is a tangent to this graph. And since the inverse is positive, have a positive gradient, which means this thing have a positive gradient, this line will have a positive gradient as well. So is this equation plus something? I don't know what that thing is. So what I know for sure is that this will have a positive gradient, which means it's a tangent, which is it touches somewhere. It's a tangent which have this shape. So it touches the point there. So they want us to find where does our graph touches. What does our tangent touches this graph? That's what they want. So let's do that. So let's go and deal with our question on the other side. Our h. So let's write h on the other side. So h of x is equal to g inverse plus k, for some k is a real number. So h of x is equal to g. We know that g is equal to 2x minus 9, equal to 2x minus 9 plus k. So this is still a straight line, because this is our x and this is our c together, because both of these things are real numbers. So the answer of this is a real number. So it's also in the form, so it's still in the form y is equal to mx plus c. So this is our c. So this is our graph. So they want us to find the point, where does this graph intersect our function f. So we want the point of intersection between f and g. That's what they want here. So you know that in order to get a point of intersection, at the point of intersection, the y values of the functions are the same. Which means the f of x and h of x are the same at the point of intersection. So we know our h of x is equal to 1 over 2 into x plus 5 all squared minus 8, which is called h of x, which is this. What is that? That is 2x minus 9 plus k. And then what? We just simplify this. So multiply by 2 all the way. What do we get? We get this time 2 times 2 here, so it will be x plus 5 all squared minus 8, minus 16, because we multiply by 2, multiply by 2, multiply by 2, everything by 2 is equal to 4x minus 18 plus 2k. So we multiply by this 2 throughout. Then we expand this. We have x squared plus 10x plus 25 minus 16 is equal to 4x minus 18 plus 2k. Then we transpose this guy to this side. So, let's simplify. So we have x squared plus 10x this side. So we have 25 minus what? Minus 16. So this is plus 9 is equal to 4x minus 18 plus 2k. Transpose this to this side. So we have x squared plus 10x minus 4x plus 9 plus 18 minus 2k is equal to 0. So what do we have? So we have x squared plus 6x plus this plus that, that's 27 minus 2k is equal to 0. So, in this point, we're told that this guy is a tangent to our function f. What does that mean? It means that this equation should have one solution, because if it is a tangent, which means these two functions only meet once, they only intersect once. So which means now this should have one root. So you did the nature of roots, and when you were doing the nature of roots, this is what you said. So now what I'm trying to say is, since this thing here since h is a tangent of this, which means these things only meet once, this equation should have only one solution. This equation should have one solution, one real solution, one equal solution. So, if you did the nature of roots, then you know that what that means is your discriminant of this function, of this equation we are trying to solve should be 0, so that we can only have one equal real solution. Should be one equal real solution. So, because when you did the nature of roots, this is what you said. Because what we're trying to do, we're trying to find x, the value of x, because that is the quadratic equation. So we know that x is equal to, we can solve using the quadratic equation, a squared minus 4ac all over 2a. So this part here is called the discriminant. The symbol of it is this triangle here. So discriminant is equal to b squared minus 4ac, which is the part that is under the square root here. It's called the discriminant. So I'm going to dwell a bit on discriminants. So let's continue with discriminant. So if your discriminant is equal to 0, what happens? If your discriminant is 0, which means this happens. So, which is this part does not exist anymore. So, your x will be equal to b over 2a. This will be your value of x. So, which is you will have one solution. So what that means is you will have one root, which is that, equal, and it's a real number. This is what happens when your discriminant is 0. When your discriminant is 0 there, your x value, which is your roots, your solutions, is going to be 1. You will have one root, one equal root, and this is a real number. Let's go. Second case. When your discriminant is greater than 0. When your discriminant is greater than 0, which means you have a positive number there. So, how will your x look like? Your x will look like this. Your x will look like this, which means it will be x is equal to b plus or minus square root of your discriminant over 2a. This will be your x. So it's the same as that. If this is positive, adding something, so if this is positive, as we say it is here, which means if you add something on b, it will become bigger. If you subtract this thing from b, your answer will become smaller than b. So adding something on b makes this solution, okay. If you say b plus discriminant all over this, your solution will be big. But if you minus this thing from b over to a, your solution will be small. So you have two solutions here. The one that is caused by what? The one that is caused by the presence of this positive discriminant. So you will have two solutions in which one will be x is equal to b plus this, which will be a bigger one, and the other will be b minus that, which will be a smaller one. So what happens here? You will have two roots, which is two solutions. And those two solutions will be unequal, because the first one will be adding this, and the second one will be subtracting this. So you'll be having this part, b minus this, for the second one. For the first one, we'll be having b plus that. So we'll be having two unequal roots that are also real roots. They are real. That's what happens when the discriminant is greater than 0. Let's go to the discriminant where it's less than 0. So if a discriminant is less than 0, what does it mean? It means you have a negative sign there, which is this thing here is negative. Now, what does that mean? So, which means you don't have no real roots. What does that mean? It means that the answer that you will get when you have a negative sign here is not a real number, because you don't have a negative, you don't have a real number that is square root of a negative something. Because square root of 2 is 1,4 whatever. But square root of negative 2, nah, that's not a real number. So if you continue with it, you'll find that there's something called complex numbers. Then you continue with them. So if your discriminant is less than 0, which means you don't have real roots. But in our case, we wanted to have one solution, which means our discriminant have to be 0. So if our discriminant is 0, then our solution should be like this, which is equal to negative b. Negative b should be negative b, because negative b should be this part only. So in our equation, the equation that we have here that leads us to this point is, because we want, so since this thing is a tangent, we want it to have exactly one solution. So that means our discriminant needs to be 0. So then this equation, which is called x squared plus 6x, what is it, plus 27 minus 2k is equal to 0. So, since we want, or we know discriminant is equal to 0, because this thing should meet once, and therefore our x should be equal to negative b over 2a plus quarter of the discriminant, which is 0. So we know that this part is 0, so it doesn't matter. So we're left with this part only. So our x is equal to negative b, which is minus 6, which is 6 over 2 into 1. So our x equal to minus 3. So this function, these two graphs meet at x is equal to minus 3, and the corresponding y value, do they want the coordinates? Okay, my phone is dead. If they wanted the coordinates, the corresponding y value, we would find it by substituting this on either equation, which is y, or this, no, not this one. They substitute on the, because this one have missing parts, which is g is equal to x is equal to 2x minus 9 plus k. We have unknown k's there. So let's use the original one, which is f of x is equal to 1 over 2 into x plus 5 all squared minus 8. We have our x to be minus 3. So f of minus 3 is equal to 1 over 2 into minus 3 plus 5 all squared minus 8. So our x value is equal to 0.5 to minus 3 plus 5 all squared minus 8. So the corresponding y value is minus 6. If they want the coordinates of that point, your coordinates of the point of intersection is minus 3 and minus 6. This is it. Hope it's clear. Not, I don't know. So if you like this, if you think this, you found this to be very helpful, please let me know by commenting on this video. You can like the video if you do, but please subscribe after watching the video. I need your support to grow my channel so that it can be recommended to many students. So the more subscribers I get, the more views, the more likes, the more likely that the algorithm is going to recommend this video to other students like you, if you found it helpful. But if you didn't, I'm sorry, my man. You can always find another one. Cheers.